Okay, now we know what a conservative vector field is. So basically, a conservative vector field is a vector field where you can find a scalar function little f so that its gradient equals to the given vector field. Okay, then your vector field f is a conservative one. Now, how do we know whether a given vector field is conservative or not? Okay, to check that, we have two tests. One test for, so this test is for the conservative vector field in R2, a vector field in R2, and this test is for a vector field in R3. Okay, so let's talk about the first test. And this test is called the cross partial test for a vector field in R2. Now, let's say we are given a vector field f with two components, p and q, and your vector field f is in R2. Now, this vector field f is conservative if and only if partial q over partial x, the derivative of the second component with respect to the x variable, partial q over partial x, equals to partial p over partial y. If your vector field f satisfies this condition, then your vector field is a conservative one. If you are given a vector field in R3, then we have a test called curl criterion. Now, okay, let's define this test. Okay. A vector field f defined on all of R3 is conservative if and only if curl of f equals to the 0 vector. And in chapter 13.1 we talked about the curl of a vector field. So this curl is grad cross f. This is the way we define the curl of a vector field. Okay. So this is the second test. Now let's consider an example. Okay, we want to show that the following two vector fields are conservative. Now in part A we have a vector field in R2. In the second part we have a vector field in R3.